Hey, we have another integral here. This one's from the UNT Integration Bee, sample problem number 10. We have the integral of 1 plus sine x over 1 plus cos x dx. I noticed there's definitely quite a few different ways to approach this, but what I want to do to start is just notice with the plus sign there in the numerator, I want to split this into two integrals. So we'll write this as dx over 1 plus cos x, and then for our second integral, we're going to have just sine x over the same thing, dx. One thing you could do on these that will work fine is you could multiply by 1 minus cosine x over 1 minus cosine x. After you do that and just simplify the algebra, you just get a lot of straightforward integrals. That's a totally fine method. But what I thought I would do instead, just to make it a little different, is to use half angle formulas. So let's take a look at that. So the way I'm going to approach this is with these double angles that we have over here on the left for sine and cosine. Just noticing that everything we have here is sines and cosines. But we have sine x and cosine x. We don't have 2x. Well, what I'm going to do here, I'm just going to adjust these formulas a little bit. Instead of using in for x, what I'm going to do is, we could do this as a substitution. I'm just going to plug x over 2 in for each of these x terms. And let's just see what we have. If we plug an x over 2 in here, we just get sine x is equal to 2 sine x over 2 cos x over 2. And then the same thing for cosine. For cosine x, we're going to get an expression which is going to be 2 cosine squared x over 2 minus 1. I just want to notice that what we really want for the denominator here is 1 plus cos x. So we can get that value really quick if we just add a 1 on both sides here. And we add a 1 here, we're going to be left with just 2 cosine squared x over 2. Okay, so now let's take what we have over here on the right and just put it back in our integrals and rewrite everything and see what we have. So for 1 plus cos x, we have this expression, which is going to be 2 cosine squared x over 2. And then for this second one, we've got our expression for sine x. So we'll just write that out. And then again, 1 plus cos x is going to be this 2 cosine squared x over 2 thing. Now from here, we're going to get some cancellation. 2's are going to cancel. We can cancel 1 cosine with 1 cosine here. Let's see if I have room for a quick rewrite here. So here I'm going to take this 2 out front and we'll write this as 1/2. Cosine squared in the denominator I'm going to write as secant squared x over 2. And then for this other expression, if I just clean this up, sine over cosine is going to be tan x over 2 dx. One quick thing before I clean up the board, notice that here we had sine of 1 plus cos x. When we plugged in the double angle formula, we just got this to tan x over 2, so that gives us another identity that tan x over 2 is the same thing as this here. Okay, now from here, the good news is that each of these integrals is really a well-known integral that we can solve pretty quickly. So we'll take our half out front. The integral of this is going to be, we're going to have tan x over 2, but because of the 1/2 here, we need to bring a 2 out front, but 2.5 is going to cancel. And then here for this term, again, we'll bring a 2 out front, but we'll get natural log absolute value secant x over 2. And this is going to be a fine answer in terms of the half angle x over 2. But since we started with just x as our angle, I'd like to get it back in that form, so we'll get an alternate form of the answer. And that's not going to be too hard, because for tan x over 2, we already found this value. So this first piece is going to be just the same thing as sine x over 1 plus cos x. Now what I can do here, since we have a 2 here, I can, by the log properties, I can bring this 2 over here and write this as secant squared x over 2. But secant squared x over 2 is going to be the same thing as 1 over cosine squared x over 2. And actually, since this is squared here, I can remove my absolute value and write this just as parentheses, because that's always going to be positive. And now from here, we can plug this value in. But because this is in the denominator, we'll just flip it. So we're going to have natural log of 2 over 1 plus cosine x. Okay, now I just want to finish this off. So I'm going to use log properties here. We're going to split this up. We're going to write this as natural log of 2 minus natural log of 1 plus cosine x. But notice that natural log 2, that's just a constant value, so that can be absorbed into our plus c right here. So I'm just going to cross that off, and this is going to give us our final solution. Sine x over 1 plus cos x minus natural log 1 plus cos x plus c. And that's it, we're done. That's it, it was UNT sample problem number 10. Hope you liked that one. Thanks everyone for watching today. Please like and subscribe. Have a good day.